Okay, so today we're going to talk about reciprocals of quadratic functions. And there are three styles of these reciprocals, and I'll just talk about them as a whole right now. These quadratic functions are going to be of the form f of x is some number, maybe 1, it could be a 2, a 3, anything, but there's definitely no x's in the numerator here. Okay, this could be of the form where I have two factors in the bottom, and those factors I'll make up numbers so that it's a little more clear. X minus 2 and x minus 3. Okay, this is one form. Then we could have a quadratic function where there's some number, maybe I'll write a 4. This number doesn't have a lot of importance on the graph, but it does have a bit. It has it shrinks or stretches the graph depending on its value. Well, this is going to have one factor in the bottom, but it's actually going to be squared. It has to be squared because remember we are talking about quadratics, and so we must have a second degree in the bottom. And so the idea is, let's say that I've got x plus 3. And then another type that we'll talk about is maybe I'll write a -3 in the numerator here. And this type is pretty strange because it's going to be x squared, but then it's also going to be plus some value. Let's go with +1. All right. And so how are all of these different? This has two factors in the bottom, which means it's going to have two vertical asymptotes. Remember, vertical is up, down. It's going to have two vertical asymptotes, and the two vertical asymptotes will be at this location and at this location, 2 and 3. This one only has one factor at the bottom, so it will only have one vertical asymptote. One vertical asymptote. Okay, this one, remember that the reason why we have vertical asymptotes is because these values can achieve 0. If this value somehow achieves 0, for example at -3, then you can't divide by a 0 in the whole thing here, and so that's why the asymptote arises. Same with this, can't achieve 0 in the denominator. In this case, this function x squared plus 1 will actually never achieve the value 0, because the reason being is because x squared is always positive. Even if I square a negative number, it's going to be positive. If I square a negative fraction, it's going to be positive. If I square a negative big number, it's still going to be positive. No matter what happens to this, x squared is going to be positive. And then if I take any positive number and add 1 to it, in the end the denominator will always be positive. So since the denominator will always be positive, you will never get a 0 in the denominator, and this has no vertical asymptotes. Okay, and these are the basic three types that we'll talk about. Two factors in the bottom, you have two asymptotes. One factor in the bottom, one asymptote. And one factor in the bottom that never achieves 0, no vertical asymptotes. And the general shape of these graphs tend to look like this, okay? Now, I'll just do a rough sketch for now. So for this one, a lot of this is just sort of looking at the graph and building it, okay? If I take my x value here and I make it positive 2, there's going to be my vertical asymptote. 1, 2, 3. So I've got a vertical asymptote at positive 2. And I've got a vertical asymptote at positive 3. Alright? Now, we have to decide what the rest of the graph looks like, okay? We do know we have these vertical asymptotes. And again, remember from last section, if there's no variables in the numerator, then I automatically have a horizontal asymptote here at 0. It's guaranteed. So now what I've got is I've got 3 asymptotes to deal with, and I have 6 distinct sections of the graph. Now the thing is this graph could kind of look like this. It could kind of go up right here, and right here. And that would be, like for example in the book here, if I look in the book, notice how we've got this same situation here. I could go kind of up and then down here and then down here, always hugging these asymptotes. So I have two options to decide from. It's either that graph or it's this graph here, where the graph is below on the sides and above in the middle, or above on the sides and below in the middle. So I have to basically decide between these two graphs right now. And the best way to do that is to find the y-intercept. So now if I look for the y-intercept, remember the y-intercept, I set x equal to 0, so I evaluate f of 0. F of 0 is 1 over 0 minus 2 times 0 minus 3, and this is equal to 1 over a negative 6, positive 6, 1/6. So my y-intercept is at 1/6, which is right there, which is a positive y-intercept. Now I know for sure that the graph is going to be in this corner and in this corner and in the bottom here. Okay? And that's basically the shape of this graph. Now one other thing that you'll want to decide is what is the value of this right here, okay? And the value of that is, you know what, I've run out of space here. I'm going to go down on this page. So I'm continuing this question here. Oop, let me just readjust a little bit. Oh, you know what I'll do? I'll do it like this. So we're still working on this same question here. We got one more thing to find out. We have to find out what is that value, because that's an important value it gives you the maximum value of this area in here, and that'll also give you the axis of symmetry, because then you'll have symmetry around this. So finding this value is actually not that difficult. So let's find this value here. And if I remember correctly, there's maybe a pretty easy way. No, actually, I think the best way is to actually take the quadratic from the numerator. So get the denominator, and make it its own function. So I'm going to call it g of x here, okay? And it's going to be x minus 2 and x minus 3. And what you want to do with this is you want to find its vertex. Finding the vertex of a quadratic is actually pretty easy. I just take it and put it into standard form. So x squared minus 2x minus 3x plus 6. So I get x squared minus 5x plus 6. So you put it into standard form. I'm finding this vertex so that I can find this point right here. All right. Now the vertex is a point, okay? And you can find it by doing negative b over 2a, and then you would do g of negative b over 2a. So you basically find, remember that quadratics have an a, a b, and a c. And so my a value in this case is 1, my b value is negative 5, my c value is 6. We're going to need the a and the b value. The a and the b value are put in here, so to find my vertex. It is a negative 5 over 2 times a, which is 1. So in this case, the vertex is 5/2. Okay, and now the y value of this vertex is g of 5/2. Okay, and so basically I just evaluate this function, g of 5/2, and it's 5/2 squared minus 2 times 5/2 plus 6, and this will be the y value here. Then I'll show you how to get from the vertex to get that point. Okay, and so let's see here, g of 5/2. Wait, okay, so yeah, so this is 25/4 minus 5 plus 6. So it's 25/4 plus 1, or 29/4. Okay, so the vertex for the parabola that exists in the denominator is 5/2 29/4. Now this point right here, I'm going to write it, is actually 5/2, and the reciprocal of this, or 4/29. Okay, there we go. And that point I found previously, it was 0,1/6. All right. And those are the two main points that we'll be able to find on this, okay? And the reason why you want to find this point right here is because now what we can do is talk about the domain. The domain is x is a real number, but x cannot equal this value and this value, which we decided before was a positive 2 and a positive 3. So 2 and 3. X cannot equal this, or that's the domain. Now the range is y is a real number such that, now the reason why we did want to find this function, or this point right here, is because now we know that the range is it's everything above 0 and then everything below this value, 4/29. Okay? And that's, oh, by the way, sorry, this is going to be negative 4/29, because it's down there. Okay, and so where am I at here? Oh yes, the range. So the range can be written in two ways. Y is greater than 0, and y is less than or equal to a negative 4/29. Okay? And so in the end, we have taken and created the graph. And the key features you're going to want to be able to get from the graph are the locations of the vertical asymptotes. You're going to want to get this point. You're going to want to get the y-intercept. This point I think is also called maybe the vertex or something, but I'm not exactly sure what this point is called. And then you're also going to want to get the domain and the range. Okay? And so that's that style. Now we're going to go with the type that has one vertical asymptote. The type that has one vertical asymptote is actually a lot easier to deal with. And so if I were to try and start building this graph, again we're going to want to get the domain, the range, the asymptotes, and some key points. Alright? So I noticed that x plus 3 squared is in the denominator, which means 1, 2, 3. Right at negative 3 is where my vertical asymptote exists. I notice that I have no x's in the numerator, and so I've got a horizontal asymptote here. Now what I want to do is again just find the y-intercept. So I'm going to do f of 0. In this case it is 4 divided by 0 plus 3 squared, or 4/9. Okay, so the y-intercept is a positive 4/9 right there. And now these ones that have one vertical asymptote always tend to look like either, I'll show you in the book, they either look like this or they look like that. And you can tell whether or not it's this one or that one based on where the y-intercept is. So in this one, you clearly have a negative y-intercept. In this one, you clearly have a positive y-intercept. And so you choose which one it is. Okay? And so this one is going to be one of these guys. Okay? And one of those. Alright? And so this is the graph of this. Sorry, of this function. And so the domain is x is a real number such that x cannot equal, oops, over here I actually wrote equal. What I meant to write is not equal. And then so over here, not equal to -3. And the range is y is a real number such that y is greater than 0. Because notice the graph exists greater than in the greater than 0 section. And this one is done. That's all we really need to find that one. You need to be able to sketch a graph and make the domain and the range. And you'll want to find the y-intercept as well. Okay, and now in the end here, no vertical asymptotes. The ones with no vertical asymptotes actually look like, well, this is a pretty poor graph in the book, but they're with a little bump in the middle here. They have a bump that goes up like that. Okay, and so the idea here is these are actually quite simple to make. Let me see if there's a better picture somewhere. Well, I'll just make it here. The ones with no vertical asymptotes are actually quite simple, again, like I said. And so we start our graph and there's no vertical asymptotes. And so basically what you want to do is just find the y-intercept. And so you do f of 0, again, -3 over 0 squared plus 1. And so the y-intercept is a -3. And so we do have a horizontal asymptote in this, remember. The horizontal asymptote is right there. And now this graph is actually going to be a horizontal asymptote. It's going to come up in a bump, right? And it'll hit, actually, this will always be the maximum point, or the minimum in this case. And then it will bump back down like that. These ones that are of this form always look like this. And now the domain is pretty easy to see. There's no vertical asymptotes. And so x is just a real number. There's no limitations on x. And y is, there are limitations on y. Notice the highest the y gets is it almost gets to 0. The lowest the y gets is -3 here. -3, 0. Oops, I messed that up. 0, -3. Okay, and by the way, I'm going to do 0, 4/9 right there. And so my range, my range is that y is between the lowest it gets is -3, and it actually can equal -3. Notice I've got that it can equal -3, but it cannot equal 0. And so the range will be something like this. The domain will be like this. So these are your three styles, really, when it comes right down to it. All right, now they're all they all have their own basic properties, but in most cases, finding f of 0 is a main. It's gonna really help you out. In this case, f of 0 is going to give you the little bump, which will tell you the range. In this case, the f of 0 will tell you this, and it basically tells you whether or not the graph exists. These two things exist above, or whether or not they exist below. And then the y vertical asymptote can be found by the factor. And then this one here is you've got two vertical asymptotes, and it's either going to be one of these guys where they're like this, or they're going to be kind of like in this other area here, and in this area here, and in that area there. Okay? And so that's basically the idea. That would be quadratics. I'll put a little bit more on the rates of change, and there's also specialized versions of these as well that we'll talk about later. For now, I'll just get these figured out for today.